Welcome back to the Topic Blast revision series. This is the day 6 walkthrough, and today we're looking at fractions, particularly calculating with fractions in a non-calculator situation. So for our first question, it asks us to write 28 as a fraction of 16 in its simplest form. Now the mistake that a lot of people make with these questions, they always assume that it should be a proper fraction. It's not always going to be proper, it could be improper. The important thing though is the order, that the first number is your numerator and the second number is your denominator. Okay, so simply it's going to be 28 over 16. Now, in its simplest form, we want to divide both of those by the highest common factor, which in this case is 4. So if we take both of those values and we divide them by 4, we end up with 7 over 4. Now that's our answer in its simplest form. Simplest form does not mean it needs to be a mixed number. Simplest form can be an improper fraction. It just means that you can't divide 7 and 4, or the numerator and denominator, by any number other than 1. So that's our answer in its simplest form, 7 over 4. Now question 2 is asking us to find a fraction of an amount. So we're looking to try and find 5/7 of 84. Now, when we're trying to find a fraction of an amount, we do two things. We're going to divide by the denominator, and then second, we're going to multiply by the numerator. So, to find 5/7 of 84, we're going to do 84 divided by 7, which gives us 12, and then we do 12 times 5, which is 60. Therefore, 5/7 of 84 gives us an answer of 60. So remember, fraction of an amount, divide by the bottom or divide by the denominator and multiply by the numerator or the top. Now the next question is asking us to add two fractions. Now when we add or subtract fractions, so we have to remember, so add or subtract fractions, we must have the same denominator. That's when we're adding or subtracting. So in this case, the easiest thing to find is the lowest common multiple. So in this case, the lowest common multiple of 5 and 4 is 20. So we want both of these fractions to be over 20. Now to get 5 to 20, we're just going to multiply this whole fraction by 4. So that gives us 8 over 20. And then on the other side, we're multiplying the 4 by 5. So we multiply the whole fraction by 5. And that gives us 15 over 20. Now that we've got our denominator the same, we simply add the two numerators together, which gives us 23 over 20. Like I said in the last question, this is in its simplest form. 23 and 20 don't have any factors that they share other than 1, so therefore that's in its simplest form. However, if you prefer, you can write the answer as a mixed number, which is 1 and 3/20. Either is acceptable. I recommend you stay here, because by getting to a mixed number, if you make a mistake there, you potentially lose a mark. Where you're not going to lose a mark if you don't do any extra work. So remember, simplest form can be an improper fraction, and the key to remember is when we add and subtract fractions, we must have the same denominator. So in this question, we're subtracting two mixed numbers. So again, like before, add and subtract, we need the same denominator. Now what I like to do here is I like to make them into improper fractions. You can do it where you do the whole number part separate and the fraction part separate and then combine those at the end, but I just prefer to make them improper. I do that every time I have a mixed number and it makes it easier for me. So when we're converting this to an improper fraction, we do 8 times 4 plus 3. So 8 4s are 32, plus 3 is 35 over 8. Take away. Then we do the second one. 4 times 2 is 8, plus 1 is 9. So it's 9 over 4. Now we need the same denominator. So in this case, we're going to use 8 for both of them. So this stays as 35 over 8. This one we've multiplied by 2. So that gives us 18 over 8. And then 35, take away 18, gives us 17 over 8. Now we have to be careful here. This time it asks us to write as a mixed number. So we must convert it. So we think, well, how many 8s go into 17? So if we need to, write the multiples of 8. So 8, 16, 24, 32. But we can see here 16, so it goes in twice, and then the difference between 16 and 17 is 1, so remainder 1, so it's 2 and 1/8. So again, if we're working with mixed numbers, I recommend you turn them into improper fractions, and then as always, when you add and subtract fractions, we have to have the same denominator. Question 5 here, we've got two more mixed numbers. In this case though, we're multiplying those two. Now when we multiply them, when we multiply fractions, we do numerator times numerator over denominator times denominator. Okay, so we always just times the two numerators and get our answer, times the two denominators, get our answer, and then we're finished. Now, one thing that we're going to use here is we're going to use something called cross-cancelling, but we'll get to that in a moment. So, as always, convert these into improper fractions. Now, when we're multiplying or dividing fractions, we must make them improper fractions. The trick that we can use at adding and subtracting, where we do the whole numbers and the fractions separate, doesn't work when we do multiplying and dividing fractions, so we need to be careful with that. So, converting this, 7 times 2 is 14, plus 3 is 17 over 7, multiplied by 6 times 5 is 30, plus 5 is 35 over 6. Our denominator stays the same. Now, there's something we can do here when we come to this, and I mentioned a minute ago, called cross-cancelling. Now, this is multiply only. It only works when we multiply. Okay, what we're going to do is we can't simplify the first fraction, we can't simplify the second fraction. However, if we look diagonally, we can simplify this 7 and this 35. We can divide them up by 7, so this becomes 1 and this becomes 5. So instead of trying to figure out 17 times 35, all we're doing in this case is 17 times 5. So 17 times 5 gives us 85, and 1 times 6 gives us 6. Now this can't be simplified any further, and the reason we know that is because we've done our cross cancelling. So if we cross cancel and we've done everything here, then this can't be simplified any further. Now, looking back at our question, we need to give our answer as a mixed number. Now, how many 6's go into 85? What's the remainder? What we can do here is just do a little bust up. 6 into 85. We're not going to put our decimal with our zeros, and I'll show you what we'll do instead. So this goes back to kind of what you probably would have learned in maybe year 3, year 4. We do 6 into 8 goes once, remainder 2. 6 into 25 goes 4 times with a remainder of 1. Okay, and that's all we need. That's going to give us 14 with a remainder of 1 over 6. So we get 14 and 1/6 as our answer. Final question now is just to divide two fractions. And again, the same thing would work if we were doing mixed numbers, just convert them to improper and then use the same method I'm about to show you. So when we divide fractions, you've probably heard this before, we do keep, change, and flip. Now, often people remember this, but what does that actually mean? So the keep means keep the first fraction the same. Okay. The change means change to multiply, and flip the second fraction. Okay. Now another way to think about that, the kind of more mathematical way to say that is when we divide fractions, we just multiply the first fraction by the reciprocal of the second fraction. And reciprocal is just when we find the reciprocal of a fraction, we just flip it over. So in this case, we're going to keep the first fraction the same, 3 over 5. We're going to change our sign to multiply, and we're going to flip our second fraction. And now we're back to multiplying like in the last question. And as we said, let's see if we can cross cancel. Well, we can do that 5 can be divided by 5, that 10 can be divided by 5. So now if we finish our question, we get 3 times 2 on the top, which is 6. 1 times 7 is 7. So our final answer in its simplest form is 6 over 7. So remember, dividing fractions, keep the first fraction the same, change the operation to multiply, and then flip the second fraction, and then we just multiply like we did before. So that brings us to the end of today's walkthrough. Really hope you found it useful. Thank you very much for watching, and I'll see you in the next walkthrough.